Welcome, guys. This is lecture 7. We are going to look at the second method. So, the second method, going to look at some examples as well. So, the second method proceeds from the Newton's-Raphson method. So, you remember that the Newton-Raphson method, we had xi plus 1 is equals to xi minus f of xi over f of prime of xi. So what we do with the second method, we have a new parameter as a representation of the first derivative f prime of xi. So what we are going to substitute this one by the definition of of the derivative. So you remember from differentiation, and if you remember from differentiation from first principles, that f of prime is equals to fx plus h minus f of x over h. You can as well consider the Taylor series expansion as well. It will also give you this formula there for your derivative. So if if xi and xi minus 1 are two initial points, then your estimate will be f of xi, f prime of xi is equals to, this one is x plus h, so it means that it is the preceding term for this one. So here you put the one which is greater, which is xi minus f of xi minus 1, the preceding term, over f of xi minus fx of I minus 1. Right, so if you substitute this f prime of xi, substitute it on your Newton's-Raphson method, you will satisfy yourself that you will get this formula, and this formula is your second method. So it has got two uh, assumptions. So the first one, you need to know the formula first. Make sure you memorize the formula for the new estimate, which is xi plus 1 is equals to xi minus f of xi times bracket xi minus xi minus 1, everything over fxi minus fxi minus 1. So there are two initial points, and then you should know that f of xi should not be equal to f of xi minus 1. Otherwise, if this and these two are equal, this will give you a 0 and the whole expression will be undefined. All right, so let's look into this following example. So you are given a function f of x, which is x squared minus 2x plus 0.5, and then you are given that x0 is equals to 0 and then x1 is equals to 1. Then this is the given information. Then you need to record the formula for the second method, which is xi plus 1 is equals to xi minus f of xi times xi minus xi minus 1 over f of xi minus f of xi minus 1. So throughout this course, make sure you memorize this number line. So this number line contains xi, so the I is in the middle, so the next term will be xi plus 1, and the previous term will be xi minus 1. So xi minus 1 will represent a term before xi, and xi plus 1 will represent a term after I. In other words, the difference between these 2 points is h, and this is h. So if you are using x, this will be x minus h, and then this one will be x plus h, because if this is x, and then for you to get here, you need to add this distance, which is x plus h, and then this is h. So if you want to use this, is x minus h. But well, let's look at the solution of that. So first thing, you need to recall the formula for the second method, which is your formula, and then you are given those two initial point x0, which is 0, x1, which is equals to 1. And then for the next estimate, for the next new estimate, which is when I is equals to 1, substitute for I in your formula. You have got x1 plus 1, which will give you 2, and then x1, and then f of x1. This is substitute there, and then this one substitute, you get this x1 substitute. So substitute everything for I from this equation. This will give you x1 minus f of x1 minus x naught, and then f of x1 minus f of x naught. Right, so x1 you know, because you are given from the question, this is your x1. X naught you know, this is your x naught, but you don't know f of x1 and f of x naught. So the next stage is to compute f of x1 and f of x naught. Right, so remember x naught is 0, so f of x naught will be, in place of x naught we substitute by, place of x naught we substitute by 0. So this will be f of 0 is equals to, where are we substituting? We're substituting for x0 on this formula there. So this will be 0 squared minus 2, 0 plus 0.5. This will give you 0.5. And then f of x1, which is this one, substitute in this formula, because x1 is 1, so we substitute for x is equals to 1 to get f of x1. So f of x1 here, this one is 1. It's 1 squared minus 2 times 1 plus 0.5, which will give us what? Minus 0.5. Right, so for our new estimate of for x will be, we substitute all the information that we have now. We have x1, which is 1. We have f of x1, which is minus 0.5. Substitute there. We know x1, which is 1. We know x0, which is 0. We know f of x1, which is minus 0.5, minus f of x0. We know f of x0, which is what? 0.5. So if you simplify and solve this one, you get your x2 to be 0.5. How about for x3? So for x3, you use the same method. So x3, you use the same method, but in this case, you need your x1, x2. You need two initial points that follow x3. So that will be x1 and x2. So this will be for I is equals to 2, and then substitute on that formula. So I, where there is an I in this formula, I put a 2, and then this will give you x3 is equals to x2 minus f of x2, x2 minus x1, f of x2 minus f of x1. Remember from the previous slide, we computed f of x1. So f of x1 we have, but f of x2 we don't have. So we compute f of x2. Remember x2 is equals to 0.5. So we substitute on our function f, but we substitute for x is equals to 0.5. So this would be 0.5 squared minus 2 times 0.5 plus 0.5. This will give us minus 0.25. Then we can then come and substitute on our method to get x3. So this will be x2 0.5, f of x2 minus 0.25, x2 0.5, x1 1 over f of x2 minus 0.25 minus f of x1, which is equals to 0.5. And then if you use your calculator, solve this will give you 0.5 minus 0.125 over 0.25, and this will give you your x to be equal to 0. So that's how we apply the second method. So in summary, for the second method, you need two initial starting point or two preceding terms following the term that you want to estimate. So if you want to estimate x5, you will need to use x4 and x3. That will give you x5. So if you want to estimate x4, you will use x3 and x2. So take note of that. So thank you. You can test yourself and try this question. Pause the video, try to solve this question. I've sketched this graph so that you know for this function f of x, your estimate when you're computing your f of x there, at least just try to make some reference, but you need to this graph. So for example, you see your x minus 1 should be somewhere there, it's slightly above 0.0, and then your f of 1 close to 5 there. This one, sorry, is about 1 or 2 somewhere there, and so on. So try to obtain these values for the next three estimates of x and try to complete this table and make reference to that. Thank you.